Hello, Rodolfo here. Data science teams use a myriad of different technologies to draw insights from diverse datasets and sources, and while Tableau's current analytic extensions are robust only for Python, R, and MATLAB, last year Tableau released an analytics extension API to facilitate ad hoc integration with many outside tools and languages. In this video, I'll be showcasing a proof of concept that I call tabjulia, establishing the initial framework for a Julia server for parsing Tableau script functions. It is far from finished, but a good starting point for anyone interested in beefing it up a bit. I use Genie.jl, a Julia web framework for developing modern web applications. The server works for running Julia code from within Tableau script functions used in calculated fields. The workflow that I represent here will consist of 1. Starting up the Julia Genie.jl backend server environment, 2. Configuring Tableau to connect to the server, and 3. Showcasing an example using a Julia script within a calculated field. To set up the Julia backend server, simply run the script provided along with an optional port number. Here Julia, the name of the script, and for the port number, I will use 8091. Wait for it to start up. And here we have the server started at localhost with the port 8091. From there, open up your Tableau desktop workbook. Under Help, Setting and Performances contains Manage Analytics extensions. From here, you can see that our server and the tabby are what usually comes with it, along with an external API, which is what we will be using. So we have our port number at 809091. It's what we specify. We test the connection, and this should request info from the server that we just created. And it worked, successfully connected to the analytics extension. Press OK. Okay, so now we're connected to the Julia server, and we can run Julia code in our calculated fields. Created a calculated field in advance here. You remember the script functions are the ones that send or post the data from the visualization to be calculated with the function or code that belongs to the respective language. Here, this is Julia code. We're going to sort the sum of sales as the first argument. I named the calculated field sort Julia. Okay, so in a visualization, we have the sum of sales by month, which is pretty much all the data that is presented in the Superstore dataset. So now when we add a second row, we can see all of the months sorted, which Julia did on the back end and sent back to Tableau. This, what I'm showing here is very similar to the manner that Thomas Foldy did when following a similar procedure to connect Tableau to Haskell. He was definitely one of the inspirations for this, and where we got the idea to implement it for Julia as well. Okay, and for those that are interested, what's going on behind the back scenes is Tableau sends data to Julia, which is in the following format. It's really just a dictionary with two keys, I should say. The script key and the data key. The script key is the code from the calculated field, which back here we saw that it was sort along with a parameter, and that is the second key, which contains the data along with the dictionary containing the data in list format for each of the arguments. Here we had the argument with sum of sales, which were then fed to the tabjulia script that we created, which really is just the value function receives or the route receives what Tableau sent as a payload. We parse the script by replacing the underscore argument with the data, then ran it and returned it to Tableau. There's a lot we could do to beef this up by incorporating tab-by features like secured encryption and pre-built analytics models that could be used in the script function, calculated field. If you'd like to discuss this, please let me know. I'd be happy to talk and see if we can collaborate to keep improving it. Thank you, and I hope to hear from you soon.